Okay. Last time we talked about double integral, right? When your region is not a rectangle. Okay. So you have to design, right? That which variable that you are going to do the integration with respect to that variable first. Okay. Now, the two examples that I gave it to you last time is that, like you decide by looking at the region R. Okay. For example, in this one, if you remember that when you draw the region, this is your region, right? And you notice that if you want to do the integration with respect to x first, okay, your y is a constant, right? So we are going to look at any constant y, okay? So if I look at this particular constant y, I draw the vertical line, horizontal line to intersect the region. I get this point and this point, okay? At this particular y that is constant, right? So you can see that this point is coming from the point on the line, and the left point is the point on the parabola, right? And if you test any particular constant y, you can see that they are the same pattern, which is the right point is the point on the line, and the left point is the point on the parabola. Okay, same thing over here. Point on the line on the right, and point on the parabola on the left. Okay, everywhere is in this pattern. So you can do the integration with respect to x first. Okay, because they are all the same pattern. Okay, but if you want to do the integration with respect to y first, you can see the problem. When you want to integrate with respect to y first, your x is a constant, right? So I look at any particular constant x, okay? I draw the vertical line to intersect the region. You can see that the point on top is coming from the parabola, and the point in the bottom is coming from the point on the line, okay? Now, let's move to another x. Let's check it here. At this constant x, you can see that it intersects the region on top. At this point is the point on the parabola, and this is a point on the line. Still same pattern, right? But things change when you look at this particular x or fixed x. You can see that it intersects the region, and the top point is a point from the parabola. I would say the upper part of the parabola. But the bottom point here is still a point on the parabola, but it's the lower part of the parabola. Okay, so you can see that this is different pattern from the first two. Okay, so when you have this, that means you cannot do the integration all the way through the region at one time. Okay, because they are the same pattern. Okay, if you still want to do the integration with respect to y first, you need to separate this region into two pieces, which is this piece, let me call R1, and the other piece, let me call R2. And then you can do the integration with respect to y. But you can see that it's more complicated than if you do it with respect to variable x first. Okay, now let me show you again this one. You can see that if I do the integration with respect to y first, So x is a constant, right? If you look at any particular constant x, draw the vertical line, okay? And then you can see that the top point is the point on the wider parabola. And the lower point is a point on the narrower parabola, right? Now, same as here, wider parabola, narrower parabola, okay? And over here, same thing, wider parabola, narrower parabola, okay? So they are all the same pattern. So you might want to integrate with respect to variable y first, okay? Now, the problem is going to uh, occur, which is if you want to integrate with respect to x first, now your y is a constant, right? Let's look at any constant y. Okay, you get a horizontal line. So you can see that there is a point on the narrower parabola, and the left point is still a point on the same parabola, but this point is on the right side of the parabola, and this is the left side of the same parabola. Okay, you might still have the same pattern, right? Of right part of the narrower parabola, and the left part of the narrower parabola. But if you look at this particular y, constant y, you see, it intersects at the region at this point, this point, this point, and this point. See, it's not the same pattern of the lower y. Okay, so since they are not the same pattern, you cannot do the integration at once. Okay, uh, because they are not the same pattern, so you have to separate into smaller region. Okay, so it's going to be more complicated. Okay, so in this problem, I might want to go with integration with respect to variable y first. Okay, now this show you that the way you decide which variable you might want to go first by looking at the region. Okay, now let me show you some more example. This one is gonna be about the function that you are going to integrate. Okay, this is going to give you the idea or the choice which variable you are going to go first. Okay, so let me give you example with find the double integral over region R of e to the power of x squared. dA where R is enclosure by y equal to x equal to 1, and x-axis. Okay, now let me tell you that in your final, if this problem is in the in-class exam, I will give you the graph and the point of intersection. Okay, you don't need to find the intersections, or you don't need to draw the graph. I'll provide to you. Okay, let me draw a graph, which is this. This y equal to x. And the vertical line is x equal to 1. Okay, And the point of intersection is 1, 1 and 0, 0. Okay. And the region I is, okay, it's enclosure by y equal to x equal to 1, and x-axis. So it's this area. Okay. Now, you can see that if we change this to integrate with variable x first, followed by variable y, okay, the problem is going to occur because now it's not about region, but it's about this guy, okay? Because if you want to do the integration with respect to x first, you can see that in order to integrate this function, you might want to think about integration by substitute another variable. Usually we use u, right? So I might want to set this to be your u. But last time I told you, right? When this method is going to work, what is your u? You take derivative, right? It's equal to 2x. And once you take derivative, you have to make sure that the x terms has to be in there. Okay, so your this method will work for you. Substitute by new variable u. Okay, but there is no x here. Then it means you cannot do this integration by this method. Okay, and if you check other kinds of method, you know, by parts, trigonometric, identity, and substitute by trigonometry, and other ways, it's not going to work, okay? So that means this function tell me that if I do integration by variable x first, it will not work. So I have to change this to this. In double integration of e to the x squared dy by n, followed by dx. Okay? And you can see that why this work? Because when you do integration with respect to y, your x is a constant. So x squared is also a constant. E to the constant is a constant. So you can do integration with respect to y in this case. Okay? So, again, if you do integration with respect to y, in this case, your x is a constant. So we're looking at any constant x. Okay? And then we have to find the running number for y, right? Again, your function has to be in the form of y equal to something, okay? Which is good, okay? Now, I'm going to try to find the running number for y, right? So at this x constant, y starting from this point to this point, okay? And at this point, it's on the x-axis, right? Which the equation of the x-axis is actually y equal to 0, right? Okay. And it run to this point, which is, it's a point on this line, which is y equal to x. Okay. At this x, you want to know the y value, you plug x in here, so you get y. So at this point, your y is actually x. Okay. So the running number for y is, it starts from this point, which is y equal to 0, up to y equal to x. See? Okay. Now, from here, you want to find the running number for x. So the running number for the outside integral has to be numbers, right? So you have to ask yourself, this region running from which x to which x? So you can see that this region starts from this point, right? Which is x equal to 0, and continue to and keep going until x equal to 1, right? Then it's finished. Okay, no more region on the right. So it finished at x equal to 1. So the running number for x is from 0 to 1. Okay, so that is the order of integration that you really want to do. Okay, not this one. Okay, and in this case, your function is a key for your decision to choose which variable that you want to integrate with respect to that variable first. Okay, and you can see the difference. This one is the region, right? Is the key for your decision to choose. Okay, which variable that you want to go first. Okay. I'll let you do the integration. And this one, see, this is a constant, right? Because we do the integration with respect to y. So after you do integration, you should have e to the x squared y. Okay. And when you do integration with this, I believe that you might want to use substitution by u. I think it should work. Okay. I'll let you try this one. Okay. Let me give you one more example. Okay. Which is find double integral. So this one, they just specify the order for you, which is start from x to 1, 0 to 1, sine of y squared dy dx. Okay. They just give you this, no more information or no more other information for you to do the integration. Okay. Now, you can see that you have the same problems, right? Which is you do the integration with respect to y. Okay. I think the only one method that I should try for this problem is, again, substitute by u. Okay. You can see that if this is your u, again, the way to check if this method is going to work, what is your u? You take derivative. Okay, since your u depends on y, because it's equal to y squared. So you take derivative with respect to y. So you get 2y, right? And see, at least y has to appear in here in order to like this method to work. Right? So you have no y here, means this is not working. Okay. So you might want to try to switch the order of integration, which is this sine of y squared dx and dy. Okay. Now, I notice that this is not a number, means I is not a rectangle. So you cannot switch the running number, right? From the inside to become outside, outside to become inside. It doesn't work that way because your region is not rectangle. Okay. Now, our task is going to be, we need to find the running number to put in here now, after we switch the order. Okay. That means you need a picture, right? How can we get a picture? Well, need a picture, right? Or a graph. So the graph that you need coming from this running number here. You can see that you do the integration with respect to y first, right? Then this is going to be the running number for y. So this is y equal to x running to y equal to 1. Okay, so that means I have y equal to x and y equal to 1. Okay, so let's draw a picture, okay, which is y equal to x should be a line, right? I need 2 points. So let me choose x equal to 0. Y has to be 0 too. So you have 0.00. And then if x is 1, y is going to be 1, right? So I have this point. So I can draw a line passing through these 2 points. Okay. And then I have a line y equal to 1. As I told you, we are in 2-dimensional. Your x variable disappear, means it can be anything. So y equal to 1 is here. But your x can be anything, so you stretch along the x-axis, right? So there is y equal to 1. And there is y equal to x. Okay. Now, this gives you some information already, but this gives you what is going to be your region. Your x start from 0 and then all the way to 1, right? So that means this is going to be your region. See, x start from 0 all the way up to 1. And then it's enclosure by these two graph here. Okay, that is from the running number of y. Okay, so that is your region. Okay, I have the region already. Then I can find the running number to put it in here. Okay, now you do the integration with respect to x first. Okay, so your y is a constant. So you're looking at particular constant y and draw the vertical line. Okay, and it intersect the region at this point and this point. Okay, this is where the y is constant, right? Now you have to ask what is going to be the running number for x when y is a constant. So the running number for x is going to be start from this x, which is x equal to 0, right? See, because this point is on this y-axis, and the equation of the y-axis is x equal to 0, and then all the way to this one. And this point is a point on this line. You want to find out what is x equal to? You plug y into this, you get that x actually equal to y. Okay, y. So your running number start from 0 to y for this constant y. Okay, and again, for the y value, okay, I would say that this intersection point is at 1, 1. And this point is 0, 0. Okay. Now, finally, you integrate with respect to y. You want to find the running number for y, right? You have to ask yourself, this region start from y equal to what? That is, it start from y at this level, right? Which is y equal to 0, right? All the way up to y at this level, which is y equal to 1. So you have 0 to 1, okay? You have to make sure that the running number for the outside integral has to be numbers, okay? Inside, you can have variable, okay? But outside has to be number only. Okay, so that is going to be the double integral that you might want to use to do the calculation. Okay, this one. Because now, see, if you start with the integration with respect to x, everything in here is a constant. Okay, so then you can do the integration now with no problems. So, any questions? มีคำถามไหมเอ่ย Okay. Now, let me do. Where's my note? Okay. Let me talk about another topic, which is double integral in polar coordinate. Okay. We cannot go into deep detail about polar coordinate, but I'm going to talk about the things that we need to use uh, in this integral only. Okay จะไม่ขอพูดรายละเอียดทั้งหมดนะครับ ก็จะขอพูดเฉพาะส่วนที่ใช้นะครับ Okay, we are used to this system. We have x-axis, y-axis, right? Now, we get used to tell a point, any point on the xy plane by using the coordinate like this, x and y. Okay? And you know the meaning, right? Which is, hold on, let me find this. G. Okay. This is the way to tell where the point is on the XY plane, which is oh, Google Assistant now. Okay. That is in order from if you want to go from the origin to this point, you walk in the X direction, which is this X unit, right? And then once you arrive here, then you continue by walking on the Y direction or Y axis direction, Y unit. Okay, then you go up Y unit. Then you arrive at this point. Okay. Now, in this system, you might see, like it's related to the right angle. Okay. And see, look like a rectangular. So we call this system is rectangular coordinate system. Okay, that is the system that we get used to. Okay, now I can look at this point in a different way to go from 0, 0, and then go to this point in the different perspective, okay, which is, well, X and Y, okay. Let's see. I want to go to this point again, starting from 0, 0, okay. The first thing that I would like to define is theta, which is an angle, okay. Measure from x-axis, okay. Now, there are two things, which is if we measure from x-axis counterclockwise ก็คือทวนเข็มนะครับ counterclockwise your angle will be positive, okay. And if we measure from the x-axis and then clockwise mean going down, right? Counterclockwise from x-axis is going up, right? So clockwise, your angle theta will be negative, okay? So, okay, if I start from this point, well, I'm looking at the x-axis. I want to go to this point, right? So I measure, the angle from x-axis counterclockwise in this case. Right? ถ้านึกถึงเนาะเหมือนมีเป้าบินใช่ไหมครับแล้วเรายืนอยู่เราจะยิงเป้าบินก็วัดมุมจากพื้นขึ้นมาถึงเป้าบินนี่เห็นไหมให้ได้ระดับเดียวกันเนาะ so we have some kind of imaginary line, okay, like this. Now, in order to get to this point from this point 0, 0, well, I get this line or this path already. So what I'm going to do is I'm going to walk from 0, 0 to this. Let me say you walk a unit on this path or this line from 0, 0 to this point. Okay. So this point, you can see that I can get to this point by these two value, right? Which is now your R and theta. Okay. This one I need two value for X and Y in order to get from this point to this point by walking, on the X-axis direction for X unit. And after that, I walk on the Y direction, Y unit. So I arrive here, okay? But this one, I use different perspective, which is to get from this point, I start from this point, and on this axis, I raise it, right? In an angle of theta, or I go counterclockwise in an angle of theta. So I get an imaginary line, right? Then what I do is I walk on this line, R unit. Then I get to this point, okay? Now, in this system that you specify your point by R and theta like this, we call it polar coordinate system นะเป็นการบอกการเดินทางมาถึงจุดได้เหมือนกันด้วย2จำนวนเห็นไหมครับแต่ในมุมมองที่ต่างกันนะครับโอเค there are more details about polar coordinates for example the name of this point in polar coordinate you can have many names ก็คือถ้าเป็นในระบบพิกัดฉากครับจุดใดๆก็ตามจะมีชื่ออยู่เพียงแค่ชื่อเดียวเนาะอย่างเช่น11อะไรเงี้ยนะครับแต่ in polar coordinate you can have many names นะครับก็คือสามารถมีชื่อได้หลายชื่อเลยผมยกตัวอย่างนะอย่างเช่น for example from this I can go to theta and then go another 180. So this red angle here is going to be pi plus theta, right? Because there is theta, I go another pi, so I arrive here, right? So I have an imaginary line like this, okay? Now, you can see that if I walk a unit on this line, I'm going to be on this point, which is called, the angle is pi plus theta, and I walk a unit, right? Now, this is the direction of a unit, but if I flip it to the other side, means instead of walking a unit, I walk negative a unit because I walk opposite side of this. Okay, so then I arrive to this point, same thing. Okay, and the other name for this point is going to be negative r pi plus theta. Okay, because if at pi plus theta, I walk r unit, I'm arrive at this point. Because I walk r unit on this angle, I arrive at this point. But if I walk negative r unit, mean I walk opposite side of this angle. So I'm going to be on this side here. And r unit is over here. So this is another name of this. See, in polar coordinate, you can have more than one name for a point. Okay. Now, there is not an important property of the polar coordinate system, but let me give you the important properties, which is relationship between rectangular and polar coordinate system. Okay. Since they define the same point, right? Then there should be a relationship between x and y and theta. Okay. So I'm going to put everything in one picture, which is in rectangular coordinate system. Let me call this x and y, same thing. Okay. Now, in polar coordinate, let's say I measure the angle to be theta counterclockwise, okay? And I walk on this line or on this path unit. So this point is also called theta in polar, okay? Now, one more note about polar coordinate. You can see that I usually start from the angle first, and then after talking about the angle, I just talk about uh, how much I walk, right, on this imaginary line when you talk about your theta already, right? Because in order to walk on this line, you have to talk about the angle first, right, to form this line, and then you walk along this line. So when you have polar coordinate, you start from the angle first, and then talk about how much you walk on that imaginary line after you raise the angle counterclockwise or clockwise. Okay. Now from this, let me form a right angle. Okay. Then you can see that from this right triangle, sorry, you have this length to be x, right? Because you walk on this x unit. And then this length is going to be y unit, right? So that you arrive at this point, which is called xy, okay? Now, you can see the relationship now, which is first, from this right triangle, you know this side, you know this side, you know this side. By Pythagorean theorem, you have that r squared is equal to x squared plus y squared, okay? And let me just talk about the result of this, which is not important, which is solve for r. You have plus minus square root of x squared plus y squared. Okay, that is, you can see the relationship between r and xy, which is this in polar, right? This is in rectangular system, coordinate system. Okay. Now, second one is you can see that we have R already that is related to X and Y. Now, let's look at theta now. You have the right triangle, right? When you have angle, you might want to think about trigonometric value, right? Which is, I'm going to relate it, this theta to Y, which is opposite side of theta. And then let me relate it to this side, which is the opposite side of the right angle. Okay, that is the proportional for sine, right? So I have sine theta from this angle. It's the opposite, which is y over r. Okay, that means if I move r up here, so I have y equal to r sine theta. Okay, and similar way, if I try to relate it, this theta to this x, which is the adjacent side, right? Adjacent to opposite side of right angle. I think it's called hypotenuse. The opposite side of this this right angle called hypotenuse. Okay. Uh, so I'm going to look at cosine theta, which is related to the adjacent over hypotenuse, which is x over r. And similarly, you move r to this side, you have x equal to r cosine theta. Okay. And number 4, if this one I try to relate it theta and y and theta and x once at a time, right? Now I try to relate it this two, which is theta with x and y at the same time. And you can see that from this right triangle, y is the opposite side of the theta, right? And this is the adjacent, okay? That is the proportion of the tangent theta, right? So I have tangent theta equal to the opposite, which is y, over adjacent, which is x. See? So these are all relationship between, see, polar and rectangular system. See, polar, polar, rectangular, same thing over here, and polar, rectangular, right? So we can convert from rectangular to polar and polar to rectangular by using these identities. Okay. Now, another thing that we are going to use, okay, is let me check if I still have the picture of what that I give you. No, I have this one, but not clear, right? If you remember, let me talk about it quickly, which is when we talk about this, remember, let me just pick dy dx, something like this. Okay, and you know that x is from a and b, this is from c and d, okay, and this is the rectangle. Okay, what I did is I'm going to integrate with respect to y, right? So your x is fixed first. So you fix any x. So you get this line. Okay, and you want to integrate with respect to y. Let's look at any y on here. Remember? And then what I did is I just construct a side which is this is on the x-axis, right? I form a side which is this small side and this small side to become dx and this side dy. And then what happened? For this particular xy, when you plug it in here, you get the z value, right? So it's going to be the height. So this is the height, right? Okay. And this is the side of the rectangle. So you can form a pole, if you remember, a pole like this, right? And then when you do the integration, you know, from with respect to y first, so the running number for y is from here to here. It means you add up the pole together, so you get the row of the pole like this, row of the pole on this line, okay? And you do the integration with respect to x, okay? So at this fixed x, you have a line of the pole, but then you have to integrate with respect to x, which is running from A to B. And each x, you have a line of a pole. So you are going to, for example, this x, you have a line of the pole. So you add them up together. So it becomes the solid object under this surface here. Okay. I don't know if you remember, but go back and do the review. Okay. But now, let me talk about this. But I want to change it into polar system. Okay. Now, let me show you this first, that when I talk about polar system, you can see that it's about the angle, So when you think about measure angle like this, you might think about something that is in the smooth curve ก็คือทำไมครับเนี่ยเวลาเราพูดถึงมุมที่หมุนขึ้นไปอย่างเงี้ยเนาะมันก็พูดถึงน่าจะพูดถึงสิ่งที่มันเป็นโค้งมนคล้ายๆอย่างวงกลมอะไรอย่างเห็นไหมเนี่ยนะครับมีการพูดถึงเนี่ยโค้งอย่างเงี้ยนะครับเป็นโค้งมนอย่างนี้เนาะ hence the polar coordinate system when you do the double integral into this polar coordinate system, it is suitable for the region that has a smooth curve, like, for example, a circle, something like that. Okay. It might not be good to something that have, straight line and sharp curve like rectangle. ก็คืออย่างเช่นสี่เหลี่ยมเนี้ยอาจจะเหมาะกับ rectangular coordinate system มากกว่านะครับไอ้ตัวเนี้ยจะเหมาะกับอะไรที่เป็นโค้งๆมนๆนะครับมากกว่าเนาะโอเค so let me give you the picture which is อันนี้ทุกอย่างก็ต้องคิดเป็นเหมือนในรูปแบบของ r กับเซตาหมดนะครับฟึบฟึบฟึบ Okay, so this is your, let me call it fxy first. Okay, now this is your x-axis, this is your y, and then this is your z. Okay, and we have this function to be z equal to this. Okay, now let me looking at the graph look like this. The region that we are interested. คราวนี้จริงๆพื้นผิวมันก็ต้องครอบคลุมมาถึงเนี้ยเนาะมันอาจจะดูแบบไม่มีอะไรตรงนี้แต่ว่าพื้นผิวก็ต้องมาตรงนี้นะครับคราวนี้เนี่ยผมจะขอวาดรูปเฉพาะบน xy plane นะครับเนี่ยโอเคขอย้อนขึ้นไปอีกทีหนึ่งแต่เดี๋ยวเราจะทำคล้ายๆนี้เลยนะครับเนี่ยที่วันรวมตัวแปรไหนก่อนอะไรเงี้ยนะครับเนี่ยจะทำในลักษณะนี้โอเคนะแล้วก็ที่สำคัญคืออะไรแต่ละจุดพอแทนเข้าไปในฟังก์ชันแล้วมันคือความสูงใช่ไหม f ของตัวนั้นคือความสูงตัวนี้นะครับเดี๋ยวนะโอเคคราวนี้ผมจะขอวาดเฉพาะตัวนี้นะนั่นก็คือนี่สมมติเนี่ยเป็นกราฟโค้งมนเนาะ smooth curve let's say like this okay now you can see that if in this case again we have to think everything in terms of r and zeta. Let me look at this as a zeta. Okay. Now, and then let me, this walk on this line r unit. So this point is at r zeta. Okay. And r zeta. Then from this, I'm going to form something like this, which is I'm going to form this, which is respect to this angle, and this very small, okay? And then I'm going to form this side. See, it's the same direction as this line, okay? So this is gonna look like a rectangle, okay? Now, how can we compute this area? It's going to be, okay? As I said that it is very small, okay? Let me call it the difference of zeta, okay? And once this angle is very small, if you want to figure out the length of this, it can be approximate by this length is going to equal to, oh, it's very small, right? Let me use D. The difference of zeta times R. Okay. And you can see that on this side, it's the side same as this line, right? In the same direction as this line, but it's very small. So let me call it dr. Okay. Now, this look like a rectangle. In order to compute the area, it's going to be d theta. Remember this? Now, so right now we have, this rectangle. And then you know that this one is the theta, the area. Okay. And when you multiply this one, you can think this as your dA. This that we have done before in the rectangular system. Okay. And when you multiply this dA in this form to this is the height, remember? Draw the surface more. Okay. Once you have this, which is your dA, multiply this, is going to be the height of this. Okay. If you do the integration with respect to r first, your theta is fixed, right? So I measure from the x-axis theta, and your theta fixed. Okay. So that when theta fixed, it intersects from this point to this point for the region. Okay. Now you integrate with respect to r. So mean you have to include or sum this pole. Okay. You integrate with respect to r. You have to ask r running from where to where. So r running from this point to this point. So you are going to have a line of a pole, right? And along this line. Right? That is how you do the integration with respect to r first. Now, that means after you finish the first integration, you have a line of pole, right? Then you do the integration with respect to theta, okay? That means your theta start from this angle to this angle, means at each angle, you have a line of a pole. Oops. And then, you have to sum, right? Every line of the pole together start from this angle to this angle. See, you're gonna have the solid object under the surface again. Okay, but it's in different perspective นะครับอันนี้งงไหมแต่ว่าถ้าไม่เข้าใจไม่เป็นไรนะครับแต่ไอเดียสำคัญก็คือว่าเห็นไหมครับจากที่ผมวาดรูปตอนแรกตัวทีนะเห็นไหมตรงเนี้ยพื้นที่คือเราจะได้เสาถูกไหมครับแต่เห็นไหมครับพื้นที่ข้างใต้เนี่ยมันเกิดจาก dx dy หรือที่เราเรียกกันว่า dA ตอนนั้นที่เราสรุปเนาะความสูงก็คือคูณด้วยเจ้าฟังก์ชันตัวนี้คราวนี้อินทิเกรตอันแรกก็ขึ้นอยู่กับว่าเราจะรวมอะไรแนวไหนก่อนว่าไปแล้วก็อินทิเกรตตัวหลังก็พอได้ผลลัพธ์แต่ละแนวเป็นอะไรก็รวมเข้าด้วยกันทีหลังมันก็จะได้เนี่ยตรงนี้แต่ที่สำคัญก็คือเห็นไหมครับในrectangular coordinate system dA มันคือสี่เหลี่ยมเนาะก็คือ dx คูณ dy นะครับแต่คราวนี้ต่างกับตรงนี้ตรงที่ว่าเจ้า dA ข้างล่างเนี่ยของ polar coordinate system เนี่ยเห็นไหมครับมันถูกคำนวณมาด้วยตัวนี้นั่นก็คือเนี่ย มันก็คล้ายสี่เหลี่ยมเหมือนกัน แต่ว่าทำไมครับ มันอยู่ในเทอมของ r กับเซตาซึ่งก็คือ r dr d เซตานั่นเองนะครับเนี่ยเพราะฉะนั้น dA ก็จะแปลงร่างเป็นตัวนี้ ความสูงก็เหมือนเดิมนะครับ แต่คราวนี้ทำไมเอ่ยเพราะฉะนั้นสรุปนะครับ we have double integral over region R, right? The function in x and y, dA. Okay. If in rectangular coordinate system, you change dA into either dx, dy, or dy dx, right? Now, for the region R, if R is a square, the running number has to be constant, and then you can switch the order right away. But if it's not a rectangle, you have to consider the region and then find the running number, okay, after you switch the order. Okay, things will be changed. It's not like your region is the rectangle, okay? Now, this in polar coordinate system, your dA is going to become r d theta, okay? And this, you can see that now your variable is in form of r and theta. Well, what you can do is you have x in terms of polar coordinate. It is r cosine theta, right? And then your y, you can uh, substitute by r sine theta in polar coordinate. See, everything is going to be in the form of r and theta now, no x and y anymore. Okay, and this is going to be the running number for r, right? And this is going to be the running number for theta. Okay, and in polar coordinate, we only have one order, which is you integrate with respect to r first, and then you do the integration with respect to theta. Okay. Okay, so let me give you an example. Okay. Let me pull up my note. See, let's see. Where is the example? Okay. Find double integral over r 3x plus 4y squared dA when r is between x squared plus y squared equal 4 and x squared plus y squared equal 1. and R is the upper part is in the upper part of XY plane. Okay. Now let me draw a the graph first of the region, which is XY plane, right? Okay. Now you know that x squared plus y squared equal to 4, which is 2 squared. Okay. That is a circle with radius 2, right? Okay. Now, you can see that I'm using the dot line at the lower part here because actually we will not use this part at all because we want the region R to be in the upper part of the XY plane. Okay, but let me draw it anyway. Okay, now this one is going to be the circle of radius 1. We are not using this part at all. Okay, so you can see the region that we need is enclosure by this circle, and we want just the upper part of the XY plane. So it's going to be just this area. Let me, this one only. Okay. Now, uh, now, what happened is you can see that the region is in a smooth curve, right? So it might be better if we want to try to work on this problem in polar coordinate system เห็นไหมมันเป็นโค้งมนใช่ไหมครับ เพราะฉะนั้นน่าจะเหมาะกับpolar นะครับ so let's start okay so we have to change everything into polar coordinate system okay now I might want to start by change this okay x and y into r and theta okay so we have 3x plus 4y squared dA. Okay, let me change this into polar first. Choose x is r cosine theta. Remember? Plus 4. But y is r sine theta. And then you have y squared, right? And dA. Okay. Now let me simplify. 3r cosine theta plus this one you have 4. And square belongs to this too. So you have square sine square theta dA. Okay. Now I change this into polar. Now I need to change this into polar, which is dA in polar coordinate is r dr d theta. Okay. Now, since I do the integration with respect to R first, I have to find the running number for R. Okay? To find the running number for R, your zeta has to be constant, remember? Now, I have to, go counterclockwise at the angle of zeta, and then it has to intersect the region, right? So let's do it this. So this is my fixed zeta, so I can form the line, right? And you can see that at this fixed zeta, you are running from this point to this point. But at this R, see, it's the same radius as this circle. So this R start from 1, radius 1, all the way to radius 2, right? Because it's on the circle of radius 2. So my running number for R is going to be from 1 to 2. Okay. Then you have to ask yourself, because you need to find the running number for zeta, you have to ask that for this region, your zeta sweep from which angle to which angle. You can see that this area here, your zeta start from this, which is intersect at this line, right? And then it sweep, right, all the way to this angle. So it start from angle 0 all the way to angle pi, right? So your running number for zeta has to be from 0 to pi. Okay. Then you have to do the integration. Okay. But for this problem, let me do the integration for you. Okay. And see if you can remember how to integrate it too. So for the first integration, let me distribute R to both terms first. So I have 0 to pi, 1 to 2, 3R squared, right? Cosine zeta, 4R cubed, sine square zeta, and then dr d zeta. Now, I have to integrate with respect to R. Zeta is a constant. Okay, this constant is a constant. So what I have is integrate this. Actually, R square is, when you do integration, is R cubed over 3. 3 cancel 3. So you have R cubed. And this one is a constant, right? This one, you have, this is a constant. So you integrate only this. So you have R to the power 4 over 4. So 4 cancel 4. And then you put the running number for R, which is from 1 to 2, d zeta. So you plug in R equal to 2, which is 8 cosine zeta plus plug in 2 for R. And then 16, right? Sine square zeta. And then minus plug 1 in for R. 1 is Q is 1. It's cosine zeta plus plug 1 in. So you have sine square zeta d zeta. So you have 0 to pi. You have 8 cosine minus 1 cosine. So you have 7 cosine left. 16 sine square minus 1 sine square. Okay. This one. Now, if you remember this, you can think as something when you take derivative equal to cosine, which is sine, right? So the integration of this is a constant, right? Integration of this is sine theta. Now, who can tell me how to integrate this one? Who remember? มีใครจำได้ไหม เดี๋ยวทุกคนยังฟังอยู่ใช่ไหม วันนี้ไม่ได้ส่งเสียงเลย มีใครจำได้ไหม อะไรเอ่ยดิฟแล้วได้ไซน์กำลังสองไม่มีเนาะ We don't have something take derivative equal to sine square. This one you have to use the technique of trigonometry. If you go back and review this in the form sine to the power mu and cosine to the power nu du. Okay, when in this case m and n are even, this case your m is 2 and your n is 0, so they are all even. What you need to do is you need to change this to be a trigonometry of power 1. Change power 2 to become power 1. So 1 sine mean s, go with subtraction, cos 2 theta over 2. See? Change trigonometry of power 2 to power 1. But you have to have double angle over here. Okay? So 15 is a constant. If I plug this with this, divide by 2 is also a constant, so I put it here. So I have to integrate only this, which is the integration of 1 with respect to theta. What is something when you take derivative equal to 1 in terms of theta? That is theta, right? And then minus the integration of this. What is something when you take derivative is cosine. That is sine. And I'm going to guess that it's going to be the same angle. But when I take derivative, remember, it is sine of something. And this something, sine of something. So this whole thing depends on variable something. This, let me call circle. It's a sine of circle. So this function is a sine of circle. So it depends on the circle. But the circle is a function of theta. So it depends on theta. Okay. So sine, when you take derivative, sine circle, take derivative with respect to circle. You have cosine of circle. And then chain rule. 2 theta, take derivative with respect to theta, you have 2. You can see that you have 2 is an extra term, right? So then you need to divide by 2 over here. Okay. And then the running number for this is theta start from 0 to pi. Okay. So what you need to do is plug in pi first. Plug in pi for theta. Plug in pi for theta. And then minus plug in 0. 7 sine 0 plus 15 over 2. 0 minus sine 2 times 0 is 0 over 2. Okay. You can see that sine of pi is 0. Again, sine 2 pi, which is actually the same as sine 0, is 0. Is 0. Is 0. 0 minus 0, so the whole thing is 0. So no more. So you are left with this term 0. So you have 15 over 2 pi is your answer. Okay. Okay. Now, let me show you that for these problems, if you try to do in rectangular coordinate system, okay, which is either you change this to dx dy or dy dx, you will see a problem, which is you can still do it, but it's going to be very, very complicated, which is, let's say if you integrate by respect to x first, so your y is a constant, right? You have to draw a horizontal line. And you can see that at this y fixed, this line starts from this, which is the left side of the circle with radius 2 to the right side of the same circle, okay? But you can see that it's not going to be the same pattern anymore if you look at this fixed y. See, it intersects the region at this point, and this point, this point. See, different pattern. So it's going to be hard, to do the integration in rectangular coordinate system. Okay. Now it's going to be the same as the other option, which is if you want to do the integration with respect to y first, so your x will be constant. So you look at any particular x, constant x, draw a vertical line to intersect the region. You can see that it starts from point in the circle radius 1 to point on the circle of radius 2. Okay. But things change if you have this fixed x. See, it's the point on the x-axis to the point on the circle radius 2. See, different pattern. So it's going to be hard. Okay. So you might want to do in polar coordinate for this one. Okay. What time do we have left? 10 minutes. Okay. Let's look at these problems. Okay. Last one, which is by double integral of -1 to 1 from 0 to square root of 1 minus x squared. Okay. X squared plus y squared. Okay. Over to the power of 3 over 2 dy dx. Okay. Now, you can see that if you try to evaluate this integration, you might be able to do it, but you can see you have square root over here when you plug it in for y, because it's the running number for y, right? After you do this integration, which is, I believe, I'm not sure if you can do the integration, okay? Because if you want to use substitute by u, you need to have y over here, okay? You might be able to do it by using the technique of substitute by trigonometric function and draw the right triangle จำได้ไหมครับแทนด้วยตรีโกณแล้วก็สร้างสามเหลี่ยมอะไรนะอันนี้อาจจะได้นะครับ but it's very complicated I think okay especially when you have square root over here too okay now if you think in polar okay now remember x squared plus y squared we want to change inside to be in polar form first right your x squared plus y squared is r squared right so it's more simple now okay so that is -1 to 1 0 to square root of 1 minus x squared. This is your r squared. Okay, so you can see that double power. You multiply them together, so 2 cancel 2. Now the problem reduced to integration of r cubed dy dx. Okay, but then this is your dA in rectangular coordinate system. But if we think in polar coordinate, this becomes d theta. See? More simple, right? And then we just try to find the running number for r and theta. Okay? And again, we don't have any information. Then we go back and draw the region. Okay? Again, where can you get the information about the region? This running number here. Okay? That is the running number for y, right? So you have y equal to 0 and y equal to square root of 1 minus x squared. Okay? So you draw a picture, which is y equal to 0. That means that is the x-axis. Okay? And there is the x-axis. Now, for y equal to square root of 1 minus x squared. Okay? Before I do anything else, I have to mention that since y equal to square root of something, this give me that the condition for y, that y always greater or equal to 0. See, y cannot be negative because y equal to square root of something. Square root of something, when it come out, it's gonna be 0 or positive only. Okay. Why needs this condition? because I want to get rid of this square root, I'm going to square both sides. When I square something, I'm going to change the value, right? Let's see what I mean. I'm going to do y square equal to square on the right side. I have 1 minus x squared. See? Then, if I move this x to this side, I have y squared plus, let me change the order of writing. Move x to this side, so I have x squared plus y squared equal to 1. See? And under the condition that y greater or equal to 0, okay? This is a circle of radius 1. Okay? But you want it where y always greater or equal than 0 only. That means this circle, the lower part is where your y is all negative, right? So you just want only the positive part. That is important things when you have the original equation like this. You put the condition for y, right? Because when you square things that is negative will become positive, see? You change the value. So you need this condition, okay? So this condition tells you that, see, you change the value, you have the whole circle, but the original problem talk about only upper circle only, okay? Now, the region here, enclosure by y equal to 0, and then the upper part is the circle, the upper part circle of radius 1, okay? Now, the running number for x start from -1 to 1, -1 up to 1. So the region that they are talking about is this one, okay? Now, you know the region, you can put the running number for r and theta now, which is you integrate by r first, right? So your theta is fixed. So let me fix theta, this one. And I have this line, right? And it intersects the region at this point and this point. You can see that from this line, you are running from 0 up to radius 1, okay? So running number for from 0 to 1. And for theta, you have to ask yourself that on this region, the theta sweep from which angle to which angle. So you can see that it starts from angle 0 and it's sweeping, right, until the angle of pi. Okay, so the running number for theta is from 0 to pi. Okay, and I'll let you do the integration by yourself, which is actually combine these two together. You have r to the power 4 dr d theta. Okay, and I'll let you do the calculation. Okay, so what time do I have left? 1 minute, right? Okay, that is going to be all the material that I would like to talk today. So on Friday, let me ask you to do the class online again, okay? So that we can have 2 hours to talk about the stuff. And let's see, next week, maybe we can just study in class if we have enough time. Or otherwise, on the next Friday, I may ask you to do online class again. Okay, if we don't have enough time. And I believe that you should turn in your homework today, right? ส่งกันบ้านกันหรือยัง Yes or no ยังอยู่กันนะ อย่าลืมส่งกันบ้านกันด้วยนะครับ เดี๋ยวจะได้ให้กันบ้านอันถัดไปเนาะ Okay, that's it for today. See you on Friday online. Okay.